Howdy, students. Okay, so today we're going to be doing an example in the Chapter 22 outline, and this particular question is actually going to be asking us how to build a confidence interval based on what we just learned about t-statistics. So there's a formula that you'll need to know, and I've actually written that here. This is the standard error formula. This one can be found on your formula chart, but this one is just one that you just need to know, okay? I'm skipping over the question about checkbooks, and we're skipping down to the one called Triphammer Road. If you haven't already taken a chance to read this question, you can find the outline posted on Google Classroom. I'm not going to be reading it on this video. So go ahead and pause it now and read it yourself so that you are familiar with what the problem's about. So hopefully you've paused and read it now, and I'm going to go ahead and say a few things about this particular question. So basically, back in Texas, this is actually really popular, like the neighborhood I live in. You see these like signs as you're passing on the street, and the sign is going to tell you, it's like a digital speed reader, and it'll tell you how fast you're going. Like it'll say, oh, you're going 22 miles per an hour. They probably have something like that here in Hungary. Maybe you've seen them before. But usually the purpose is to tell you your speed in hopes that the people who are driving are actually going to follow the speed limit because they're being reminded of what their speed is somewhere other than their own, speedometer. But the people in this neighborhood are not convinced. And in fact, they want to persuade the village that they need to add extra police patrols. So they're going to be trying to do a test here. This guy basically stood on the side of the road and he's watching, and these are the speeds he gets. And he just kind of wants to see if maybe there's enough evidence with the data that he collected to show that they really should get some more extra police patrols because it's not working. So let's kind of break this down and see if we can actually use a confidence interval to prove the guy's point, okay? So the first thing I'm going to be doing is I'm actually going to, for any confidence interval, I need to have my conditions. So let's go ahead, before we even dive into the statistical question, let's go ahead and state our conditions here. So the conditions that we would need for this problem is, of course, the first one is the independence. Okay. And so the independence condition is very simple. We can just talk about the cars. The cars are the things that we're recording the speeds for. So we could say here that the cars are independent of each other. Okay, so then now I can skip on further and I can go to talking about randomization. So this condition, of course, has to do with how the cars were selected. Now, here's a question. It says here, he could see the detector and recorded the speed of the vehicles passing in it during a 15-minute period one day. So did he randomly select these cars? Not really. Actually, he kind of did a convenience sample. He just saw whatever cars were coming in that 15-minute interval. Okay, so here I could say, this is a convenience sample. But I have reason to believe that it is a representative sample. So let me talk a little bit about why I'm writing this. Well, here's the deal, okay? I have no reason to believe that these cars were necessarily trying to travel together or that they were all going to be a bunch of random speeders. We can safely assume that whatever cars pass by in 15 minutes are not going to be tampering with each other. So I have reason to believe that it's still a representative sample even if it wasn't randomly selected. Okay, 10% condition. You probably know back of your hand now. So of course here we just talk about the number of cars that were selected. So if I look at my different, oh, this is so funny. This number I was talking about like putting speed somewhere, but there's actually 22 numbers here because if you look in the column 1, 2, 3, 4, 5, 6, 7, 8, 8 times 2 is 16. 16 plus 6 is 22. So that's really funny. I didn't mean to actually do that, but my sample size is 22. So I can assume that 22 cars is less than 10%, or less than or equal to 10% of all cars that travel on this road. Because for this particular problem, we're just really looking to see if on this particular road, do they need to have more officer patrols? Okay, let's move along. Now, this next condition is the most interesting condition, and I'm going to put a little star here because this is like us going back and reviewing something that we haven't maybe done in a long time. So this is the nearly normal condition. Now, you only use the nearly normal condition when you're talking about means. And the reason that we're looking at means on this question is because, well, it actually says here, let's build a 90% confidence interval for the mean speed of all the vehicles traveling on Triphammer Road. And remember, this is the cars that travel on this road, the Triphammer Road. So the nearly normal condition is a really interesting one because here I'm checking to see if my sample size is large enough, okay? So here I'm going to check, is n greater than or equal to 30? Well, what was my n? My n for this problem is 22, which unfortunately is definitely smaller than 30. So I can't use the central limit theorem to guarantee a normal model, but I could still check to see if my data is somehow normal. Well, what can I check to see if my data is normal? Okay, so what we can do is we can actually graph our data and use a box plot or a histogram or a normal probability plot to show that it is. Okay, so I'm going to use a box plot for AP purposes is actually the quickest thing to graph. So I'm going to go ahead and use a box plot to prove that this is still normal even though my sample size is too small. So I'm just going to write the word box plot. This is my little title for my graph. And what I'm going to do is come over to my calculator and they give me a list of the data. So I'm going to take all the data and yes, I'm going to put it into list 1. So I'll go to Stat, Edit. If you have anything currently in list 1, I would go ahead and go up and just delete all that you have in list 1 currently. So I'm going to click Clear at the top of list 1. Okay, and I'm just going to go through and enter all this data. I'm going to go ahead and pause my video so that you can have a chance to go ahead and enter your data as well. So now that I've recorded and entered all of my data, and I want to make sure I always click enter after the last set, what I'm going to see is that the last piece of data is this 20-second data. So that's another way I could see what my sample size was, right? Now, if you remember, to create a box plot, what we're going to need to do is actually create a stat plot. So I'm going to go to Second Stat Plot. I'm going to go to where it says Plot 1 and click Enter. I'm going to click On to turn on it. And then if you remember, you actually want to select the box plot option that has the 2 dots next to it. So I'm going to go ahead and click Enter there. It already has my X list set up as list 1, so we're good. Doesn't really matter what kind of dots you choose to use here. So now I'm going to click over to Graph. And remember that you need to make sure that you're doing that like the Zoom Stat 9, right? So I'm going to go to Zoom, and then I'm going to go down to 9. If I click Zoom 9, it will give me a very nice graph here, okay? Now I want to trace kind of the big essential parts of this graph, so I'm going to click Trace, okay? And all I'm going to do, this should not take you very long. You don't need to make it like super duper fancy or anything, but it does need to be labeled and it does need to be to scale. So I'm just going to go ahead and set up a box plot. So I'm going to draw a line here at the bottom. Okay, I want to make sure I include my 5-number summary, which are these numbers. So my minimum is at 24, so I'm just going to put a line here at 24. And then I'm going to arrow over. Remember, I clicked Trace. So now I'm arrowing over, and it looks like my quarter 1 is, My Q1 is at 29. I'm going to click arrow over again to get to, this is my median. Ooh, that we haven't talked about that in a while. And that's at 31. Arrow over again. 34. And then my last point, which is my maximum, is at 38. And I'm just going to go ahead and put that here. Okay, so now I can just very quickly connect the dots, make it look something like what it is on my calculator. This line should really be a little bit over. Okay, great. So I just basically copied this over, and I did just a complete kind of stat copy of this. Okay, so it shouldn't take you long to draw the box plot. That's the bottom line. Very last thing I want to do is add a label here. Okay, so what's my units that I'm using on my box plot? Well, I'm pretty sure this was measured in miles per hour. Yes, it was. So I'm just going to put MPH to talk about my miles per hour. Now, what do you notice about this box plot? Why did I want to look at a box plot? Well, I wanted to see if I could still use a normal model. So I really want to see if my box plot looks symmetric and if it looks approximately approximately symmetric, I guess I should say. Does it look unimodal, and does it look like there's no outliers? So I'm kind of checking to see if it's a normal model, okay? Now, the problem with a box plot, even though it's the quickest thing that you have to graph, and yes, for AP you would have to graph this on your paper, but like I said, it doesn't take long. The thing about box plots, though, is that it doesn't show if it's unimodal. So what you're going to do is you're going to do a quick sneak peek of the histogram. So all you have to do here, you don't even have to draw it. You're just going to go to second, stat plot, and change your same thing. You're going to go over to histogram. You don't need to change anything here. You're going to graph it, and then you're going to go to zoom 9 to change it so that you can see the graph a little bit better. Now, unfortunately, this graph is like, oh, okay, much better. Once I click zoom 9, I can see. Now, you tell me, is it unimodal? The only thing I can't see on my box plot is if it's unimodal, but this is definitely unimodal according to my histogram. Okay? So all I have to do now is kind of describe what I just saw. So I'm going to say, since, okay, this is how I'll begin this paragraph. Since the sample distribution, so what is a sample distribution? So just a reminder, the sample distribution is just the distribution that we have on our sample, so the box plot. So since the sample distribution of speeds is approximately, well, let's see, approximately symmetric. Can it be perfectly symmetric? No, right? In the real world, we just don't have perfectly symmetric data. It is definitely unimodal. And how did I find out the unimodal? I'm just going to make myself a quick note that to figure that out, you don't have to write this on your paper, but this is just a note to me. You had to sneak a peek at the histogram to make sure, because unfortunately box plots do not show shape. Okay, so we know from the histogram that it's unimodal and has no outliers. So those are the three things I want to check. Okay, then the sampling distribution of, okay, mean numbers. I could say here mean number of speeds, or I could say mean, I'm just going to go ahead and say mean speeds, actually. So mean speeds is nearly normal. And I'll talk a little bit about what this means. Oh, sorry, nearly normal. Okay, so why did I have to state that it was nearly normal? So basically, because my sample was the distribution was approximately symmetric, unimodal, and had no outliers, we can assume that if we did this a bunch of more times, we would probably still end up with a normal model. Remember, when you do it over and over again, it's called a sampling distribution. So we can assume the sampling distribution. So notice that my word is different. This is a sample distribution. The sampling distribution is going to be nearly normal. Okay, and the sampling distribution of the mean speeds is nearly normal. So now, after I've checked all of this, I need to go ahead and say my final since condition, okay? And here I can say, since all conditions are met, I can do then here I can call this a one sample t interval. So here we're going to say one sample instead of saying one proportion. We say one sample t interval. And if I wanted to, I could say for means, and that would just remind me that this is going to be for means. This name right here, though, is going to be the name of what you would also use in the calculator. So it's important to name it using that wording, okay?